Dear students, welcome to the knowledge series on page replacement algorithm. Today I am going to discuss on least recently used. Now before I start this page replacement algorithm, let me show you how this particular table is appearing. Here I am showing you one blank form. If you try to see this one, normally here there is a sections in the y-axis, string, frame status is being shown. Whenever the page replacement algorithm problem is appearing in the university exams, they normally specifies the what is the string page reference. So based on the number of pages that is being appeared in the question paper, you have to put down here in these sections. Now they will ask the frames, suppose 3 frames, and depending upon number of frames it is you have to create a number of rows, and on the bottom you put as a status, because that is easy to identify whenever the page hit is appearing. Now when you write this particular page number or a page reference in this x-axis and the number of frames, then based on that, based on the request of the individual page by the CPU from the secondary memory, this is secondary memory pages, to the main memory or the RAM, this page, since it is a blank space, so whenever the first page is appearing, this we termed it as a page fault. All the blank pages, wherever the pages is appearing, it is termed as page fault. And if any pages which is not there, and if the page is appearing and that page is replaced based on the algorithm, then we consider again in the category of a page fault. Even if it is not there, then also page fault, and if it is replacing also it is a page fault. And whenever there is a same page number, same page is appearing in the particular rows from the column segment, then that we termed it as a page hit. So based on this you have to compute page fault, page hit ratio and miss ratio, where page fault is the number of pages that is being appeared for the first time, and page hit is nothing but the number of repeated pages, and hit rate is nothing but the page hit divided by the total number of the reference page strings into 100, and miss ratio is nothing but the page fault divided by total number of reference page strings into 100. So let's see the recently least recently used. Now LRU is almost all like a FIFO, but the only difference is that whenever there is a page hit, from then that particular point is termed as a 1, because it is going to refresh the memory. So when once the memory is refreshed, then that old data is being erased, and the memory will be considering that is the first page. So that's why it is termed as least recently used. Recently, so after the hit only it will be considered. Now let's see, the first page is appearing in this box, so this is considered as a page fault. When the second page is coming, this is already appearing in this frame, so it will go to the next page and it will look for the 2. When the third page is coming, already 1 and 2 is there in that frame, and it will look for the third space in the third page, so 1, 2, 3. When 1, 2, 3 appears here, it will look for the least it will look for the pages, just like in the FIFO scenario, that which appear for the long time. So 1 has appeared for the long time, so 4, 2, 3. When 4 to 3 appears here, the page 2 is again coming, and this page 2 of the disk is appearing in the RAM, so it becomes a page hit. So that means that page is already there in the RAM, so page hit, so star is given. When 1 is appearing among these 4, 2, 3, you find the 3 is for a long time, so it is replaced 3 by 1. So 3 is coming out and it is swapped by 1. Then 5 to 1, when 5 is coming, it is replacing the 4, and so 5 to 1. When 6 is coming, among 5 to 1, 2 is repeating for a longer time, so 5, 6, 1. When 1 is appearing, 5, 6, 1 is hitting because of the page available in the RAM, so it is hit. When 2, 6, 1 coming, among this 5, 6, 1, 5 is appearing for the more times as compared to the 6, and as I told to you, here 2 is coming for the first, here this 1 after the hit it become refresh, so it is 1. The same here, after the hit it becomes 1, so it is 1. So this is for a long time, so 2, 6, 1. Now when 3 is coming, 6 is for a long time, so 2, 3, 1. When 2, 3, 4 is coming, 1 is for a long time among 2, 3, 1, so 4 is coming. When 1 is coming among 2, 3, 4, 2 is for a long time, so 1, 3, 4. When 2 is coming among 1, 3, 4, 3 is for a long time, so 1, 2, 4. When 7 is coming, 1 is 4 is for a long time among 1 to 4, so 1 to 7. When 6 is coming, among 1 to 7, 1 is for a long, so 6 to 7. When 3 is coming, among 6 to 7, 2 is for a long time, so 6, 3, 7. When again 2 is coming, among 6, 3, 7, 7 for a long time, 6, 3, 2. And finally when 1 is coming, among 6, 3, 2, 6 is, so 1, 3, 2. This completes the entire table. Now next we have to find the page fault. So page fault is nothing but the number of the CPU request and appearing for the first time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 page fault. And page hit 1, 2. And hit ratio is 2 divided by total number of pages, 19 into 100. And miss ratio is page fault 17 divided by 19 into 100. So this covers the least recently used numerical problem. Thank you.